Hello everyone. So again welcome back to the latest lecture session. So thus far I believe we have looked at a couple of examples and then looked at the course outline in greater detail, right. So as mentioned in the course outline, we are going to dig right into the relevant law, let us say, at least the one promulgated by the central government anyway, right. And we do have, I guess, some minor modifications from state to state, but rarely do states have more stringent conditions or such, right. But anyway, let us look at the relevant law here, and before we dig into the law, let us look at, I guess, how the law comes about, let us say, right, or what are some of the process behind that particular law coming into picture, let us say, right. So here, I guess, looking at this particular aspect here, we see that this is the actual document here, let us say, right, of the law. I have a few aspects that are highlighted. So again, this is published, was published in the Gazette of India, let us say, right, and that is where you have most of the what do we say, rules and laws and such that are given out. And what is the relevant industry here? Obviously not industry, pardon me, the relevant ministry. It is the Ministry of Environment, Forest and Climate Change, right. Again, that is the relevant industry here. So moving down further, how does it come about? Let us say, as we see here, they publish draft rules, right, and they were published in 2015. So draft rules were published, right, again, and I believe Gazette of India, again, as we talked about, under some particular what do we say, some particular document number. And then what do they ask for? They ask for comments or such, or any other suggestions, objections from the relevant public or industry or such, let us see. And I believe they typically have 60 days, right, typically 60 days. And once at the end of this particular 60-day period, and depending upon the quality and such of the suggestions or objections that come up, they are considered, taken into account, and then it is promulgated into a law by the Parliament. And I guess here we see these aspects here. So objections and suggestions were invited, and I believe 60 days, they look at it for give a period of 60 days, and then they are considered, let us say, have been duly considered by the central government, right. And then in exercise of the Environmental Protection Act, in exercise of the powers from Environmental Protection Act 1986, right, they were replacing the previous law, which was hazardous waste management, transboundary handling and transboundary movement, I guess, right. Hazardous waste management, handling and transboundary movement. So there was already a particular law existing in 2000, right. So this particular law, which came about in 2016, I guess, right, now supersedes this particular law. And what is this current set of rules are called? Hazardous and other waste management and transboundary movement rules of 2016, I guess, right. And I believe one key aspect where this differs from the previous particular set of rules, the one in 2008, is that the emphasis is now on what do we say, minimizing, what do we say, proliferation of these hazardous waste, as in they want to prevent generation of the hazardous waste and also promote, let us say, recycling of these hazardous waste whenever feasible. At least I would say that is one particular aspect that the current rules give a greater push to, right. So before we dig further, let us say, let me look at or show you a few of the major aspects that we are going to come back to and look at later on, right. So different definitions and such, we are not going to go into that in greater detail though, right. So as we just went by, again, obviously by law we have different definitions for different aspects. So again, here this is what I was trying to get at, right. So here it is the procedure for management of hazardous and other wastes, right. So here the key is that it is prevention, minimization, reuse, recycling, recovery and safe disposal. So these are the key aspects upon which, let us say, the relevant thrust is upon, as in prevention, minimization, reuse, recycling and then recovery and then safe disposal, I guess, right. So these are the aspects that are going to be considered, right. And then moving on to the other relevant aspects, we have the responsibilities of the state government and so on. We are going to come back to this in greater detail later on though, but there are a few other aspects that I would like to highlight here. Okay. So, one aspect that is usually given short shrift in Indian context is the packaging, labeling and transportation of hazardous and other wastes. As in, I guess from time to time in news you might have seen, let us say what we say, examples of hazardous waste being spilled open into the on the roadways, and that leading to, let us say, considerable, what do we say, contamination of a wide area, let us say, or hazardous what do we say, substances traveling over considerable distances and affecting people though. So, in general there are specific ways that they need to be, what do we say, labeled, so that it is easier to identify and classify, so that if particular, let us say in an emergency situation, let us say, right, the relevant responders can act accordingly if they have the relevant information. As in, you do not want to spend time figuring out what the waste is about, how do I get more information about this waste, right. So, these aspects obviously are relatively given short shrift, and that is the reason, let us say, that I wanted to point out. So, then again, as I mentioned, we are going to come back to these aspects later on. So, and then here we come back to schedule 1, I guess, right, schedule 1, and what does that contain? It contains a list of those processes that are listed as those processes that generate hazardous waste. So, let us say you have a particular industry out there, or you are the owner of a particular industry, and some of your process are listed in this particular category. So, then obviously you would I guess need to be on your toes and look at whether your waste, not whether, typically if the process is listed, generally let us say the waste generated from that particular waste would be classified as hazardous waste. For example, here we have petrochemical process, and then the usual kinds of hazardous waste that are generated from this particular set of process, and then we have an exhaustive list of such process, I guess. Again, while I do say that it is an exhaustive list, right, keep in mind that as India becomes more industrialized, we have new kinds of industries coming into the picture and so on. The laws or rules, in my limited experience, let us say, are still playing catch up, right. So, again, there are still some loopholes, but at least right now, because it is 2018 and the rules came about in 2016, I guess they are relatively up to date, right. Again, that is one particular aspect that I want to point out. And then moving on, schedule 2, right. Schedule 2 gives you an idea about the different hazardous wastes and their threshold concentrations, right. And keep in mind that we are going to look at how do I come about this concentration. Let us say, for example, I have soil that is contaminated with some particular toxic compound, let us say. How do I know, let us say, if this contaminated soil classifies as a hazardous waste or not? So, what do I need to do? I need to conduct the TCLP test, or the toxicity characteristic leaching procedure test. So, I guess as you see here, class A type of compounds or regulated compounds, they are based on leachable concentration limits from the TCLP, or toxicity characteristic leaching procedure, and this TCLP was what do we say, developed by EPA. So, more or less what does it mean? It tries to replicate the worst possible conditions out there, as in, let us say, the test tries to reproduce the conditions that would come about if this waste is not treated, let us say, and is dumped in a municipal landfill. And there the presumption is that, or the assumption is that, acids are formed, right, in a landfill, municipal landfill. Acids come into contact with this particular what do we say, toxic waste, let us say, and then the contaminants are going to leach into this particular acid, and then again you have your contaminated leachate potentially contaminating your groundwater. So, the conditions are tried to mimic, the conditions in the test try to mimic this worst case scenario, as in you add acetic acid, which is what you would you would presume would be formed in your landfill, and you would mix it vigorously for, or end over end mixing for 24 hours, right, and then look at what would be the concentration after this equilibration over 24 hours, let us say, in this particular leachate or the acetic acid, I guess, right. And then you are going to look at the relevant concentrations, and if the concentration in this particular acetic acid, after it has been in contact with your, what do we say, your contaminated soil, let us say, or contaminated mixture, let us say, for 24 hours turns out to be higher than this value, then you would need to classify that particular waste as toxic waste or hazardous waste, pardon me, right. So, that is one particular aspect. So, again we are going to discuss this in detail later on, but these are the aspects that you need to keep in mind for now. again a relatively exhaustive list of different compounds, right? Again that keeps what do we say changing from time to time too, right? And TCLP method is well defined again, right? And for some types of compounds there is also this waste extraction test or WET, and usually let us say not usually, that was what do we say, I believe taken in from based on what the California Code of Regulations use or have developed. So typically California has more stringent regulations and they developed this WET or wet test, let us say, or waste extraction test, right? That's in general relatively more stringent compared to the TCLP test, I guess. Again, for some compounds obviously looks like we need to look at the wet test. Again just a brief overview, right? And there is one final aspect. So and then other than looking at these listed contaminants, right, we also have another classification to what do we say, consider whether waste is hazardous or not, and that's based on its characteristics, as in if a compound exhibits or is deemed to be flammable, let us say, right. So again flammable, we have the relevant conditions, if it is corrosive, if it is reactive or explosive as we see here, right. So if it is flammable, corrosive, reactive or explosive, and toxic again based on the LD50 test. LD50 test meaning the lethal dose at which 50% of your particular test population die, but usually that is not looked at. We now move on to reference doses and slope factors for either the non-toxic or carcinogenic compounds. So more on that later. So again generic overview, here we have set of rules, let us say, and they were promulgated in 2016, right, and this is an exhaustive or relatively up to date and exhaustive set of rules, let us say. It obviously contains what now, the process that are listed as generating hazardous waste, and obviously the types of hazardous waste generated. So that is something out there, and again the kinds of waste and not waste, pardon me, contaminants, right, and the threshold concentrations above which a particular waste is deemed to be hazardous waste, right. And then again you have the relevant classification based on the characteristics as in corrosiveness, right, toxicity, flammability and so on. So again at this particular point in time we are going to look at only these aspects, but again over the due course we are going to look at this particular set of laws and the other particular promulgations, let us say, or aspects in greater detail, right. So again I will move on to the next aspect for now. So I guess as I mentioned earlier, we are going to look at risk assessment, right. So let us say after conducting this particular TCLP test according to the relevant regulations and this hazardous waste rules, I found out that this particular waste is hazardous, let us say, right. So what do I need to do or such now? For that, first let us say if I have contaminated soil, let us say, right, let us say side view, let us say, and this is contaminated soil here, let us say, and let us say I have a population cluster here, right. So I need to look at what is the risk posed by this contaminated soil to this particular populace out here, right. How do I go about that? Obviously as I mentioned earlier, we need to have some scientific basis that would allow us to quantify it, as in I can't be subjective, as in let us say if I say hi, the industry guy who contaminated this particular soil might say okay, the risk is relatively low, right. And obviously let us say if depending upon the type and kind of media out there, it can lead to sensationalism too, right. So again to be able to cut that out and give greater clarity, let us say, you are going to look at risk assessment, right. So obviously we are going to move on. So again when we talk about it, what is risk, I guess, right. So I mean we talk about taking risks in life and so on and such, right. What is risk now? Anyway, I would say that it is a calculated gamble. Whenever I say I am taking a risk, it means I am taking a calculated gamble, right, with certain objective in mind, as in I have certain objective in mind, let us say, and I do know some of the ill effects or adverse effects, but I am trying to balance between them, and if I think that the chances of these adverse effects, let us say, are relatively low, I am going to go ahead with this particular, taking this particular risk, I guess, right. Say, I mean risk can be death, risk can be, let us say, feeling tired and such and so on. Let us say for example I need to get to a particular place, let us say, and public transport, let us say, is what do we say, relatively cheaper, private transport relatively costlier, but public transport might lead to my condition or appearance being remarkably poor by the time I arrive at my destination. So maybe I am not going to take that, so I am evaluating the risks here, and so thus maybe I will go with my private transport and such, right. Again, risk can be, any adverse effect, I guess, right, or probability of adverse effect or adverse outcome, I guess, right. So, what is risk? Again, it is just nothing but probability of some adverse outcome. So, in our context, as in remediation of contaminated sites or contamination, let us say, what do we typically look at with respect to risk now? We look at, let us say, effects of the toxic compounds on the humans. Sometimes we see hair fall, lesions or tumors or carcinogenic tumors, right. So, in this context, usually we look at human health, I guess, adverse human health effects, right. So, let us move on. So, when let us say, I guess we did talk about this briefly. So, let us say different people have different levels of acceptability of risk, right. Let us say I am traveling somewhere out there on a busy destination, let us say, right. A person used to that particular travel, or let us say who needs to get that particular, who needs to travel by that route every day because his livelihood depends upon him traveling through that. Let us say for him that might be acceptable risk, let us say, based on his perceptions out there. But a person, let us say, who is relatively well off, let us say, I am just giving a generic example here, might feel that okay, the risks are too great in traveling by that particular route and by that mode of transportation, and might choose other, what do we say, modes of transportation. But here in this context of contamination and so on, obviously what do we need to look at? We need to look at, let us say, how do we go about quantifying risk, right. So, what is the acceptable risk here? So, we do have a number here, typically I believe 10 power minus 6 or 1 in a million, right. So, if the chance of contracting this adverse outcome or facing this adverse effect or outcome is greater than 1 in a million chance, then we say that the risk is too high, certainly for carcinogenic effects, I guess, right. So, in this context, when people say it is safe, again keep in mind that it is relative, as in there is no such thing as zero risk, right. There is no such thing as zero risk. So, it just, when we say safe, what does it mean? The probability of the adverse outcome going through or occurring is remarkably low, right. So, again objectives of risk analysis, I guess, obviously as I talked about it earlier, I am going to try to balance my particular what do we say benefits, right, say, with the risks or possible adverse effects that I am going to receive, right. So, once I can quantify the risk, then I can look at the relevant benefits or such, and then I am going to what do we say, come to a relevant balance, I guess, right. So, in this context of contamination, how is that going to help? As in, it will help set target levels of risk. For example, let us say the risk right now turns out to be 10 power minus 4, right, and how will this help me now? Let us say it helps me in such a sense that I know that the risk, the acceptable or regulatory thresholds of risk for carcinogenic risk are 10 power minus 6, let us say. So, then I need to look at what are the options available out there, or the remedial options out there, such that the risk comes down from 10 power minus 4 to 10 power minus 6, right. So, risk analysis obviously helps in such a way. So, obviously again as we discussed, obviously different programs or different remedial options, different levels of attenuating the risk or decreasing the risk. So, I am going to choose the relevant alternative accordingly, right. So, again even after remediation, let us say, right, you are still going to have some risk, and I am going to be able to analyze that particular aspect, right. As in, after my remediation, what is the residual risk and how much risk have I reduced, right. So, obviously depending upon that, I will choose from one alternative to the other, again based on the amount of resources I am putting into. I mean, we do not live in an ideal world. So, ideal world, I guess, we have unlimited money, resources and willpower, but that is not the case, right. So, obviously in this context, it is a balance between the level of risk that we can decrease it by, and also the amount of resources that need to be put in and such, right. And let us move on. So, legal aspects of risk in general in Indian context, let us say it is not clearly defined though, but it is relatively clearly defined out there. But one particular illustrative example that I would look at, let us say, or try to look at is, let us say, how would you go about legislating, let us say, a new drug, let us say, as in different pharmaceutical companies, right. Obviously they are working for profit and obviously for the betterment of human health too, I guess, right, obviously too. So, again let us say how do they go about it? Let us say they do their tests and such, and then come up with, let us say, a drug for a particular kind of to treat a virus, let us say an antibiotic, let us say, or any other disease and such now. So, how do we go about saying, let us say if there will obviously be side effects, right, you are taking any medicine in general, depending on the dosage, level of usage, frequency and duration, there will be side effects, right, on different kinds of people. I mean, infants relatively more side effects, pregnant ladies more side effects, I mean the susceptible population relatively more side effects, relatively healthier, and such population relatively less side effects in general, right? But again, how does the regulator come up with such a mechanism to be able to decide which risk, or do the side effects pose an unacceptable risk or not, right? For that, obviously after clinical trials, let's say, we come up with what we say, again as I mentioned, 1 in a million chance of risk, I guess. So if the risk is greater than 1 in a million chance, or the side effects, let's say, are let's say any toxic side effects, let's say, can, what do we say, lead to a greater chance, or the probability is greater than 1 in a million, then we say that the risk is unacceptable, right? So if it's below that, it's more or less, we define that at our current levels that it's essentially 0, or it's a virtually safe dose, right? Safe dose meaning the risk is so small that there is no such regulation or such further regulation or such that's required in this context, right? Again, just an illustrative example, I guess, right? So why are we looking at that? Let's say when we are looking at risk assessment, we want to look at, let's say, the level of agent, let's say, or this particular contaminant that would produce, let's say, the adverse effect in 1 in a million exposed individual. So in this context, when I am talking about 1 in a million, it's typically with respect to carcinogens. So let's say for non-carcinogens, we have a different set, let's say, and that's going to be the hazard index. We are going to discuss that in due course too. And in general, all these examples, the reason I am looking at 1 million is it's very much relevant to the carcinogens, I guess, right? So legal aspects, again, risk assessment, we need to look at, let's say, reducing the risk to 1 in a million, and that's what we are going to look at. What level of agent will produce this effect in 1 in a million exposed individuals, right? So if million people or 10 power 6 people are exposed to this particular contaminant for at a certain set of conditions, let's say, well, more than one person be facing the adverse outcome, or what, not what, I guess, or what else, and then based on that we are going to look at the legal options available for addressing this particular risk, I guess, right? So moving on, I have one particular illustrative example here that I want to look at, as in, again, on a lighter note, I guess, right? So here we have different activities that can lead to what do we say, death, I believe, not death, different kinds of risks. And here we have the type of risk, I guess. So here again we have activity, right, different types of activities, right, say, and the risk associated with it, or type of risk. And here I guess it's for 1 in a million chance, I guess. So 1 in 10 power 6 for 1 in 10 power 6. So I guess some of the aspects that are, I guess, slightly surprising, I guess. Keep in mind that this data that I have is from 1979, so obviously the situation would have changed from then. But again, some of the aspects obviously are not greatly surprising, as in smoking 1.4 cigarettes will lead to, let's say, cancer or heart disease at 1 in 10 power 6 or greater than 1 in 10 power 6, I guess. Well, nothing surprising in that, right? Or spending 1 hour in a coal mine will lead to, it seems, black lung disease, again with risk equal to or greater than 1 in 10 power 6. But one, I guess, on a lighter note, surprising effect is living 2 days in New York City, I guess, at certain conditions in 1979, I guess, due to air pollution, let's say, the relevant effects seem to be greater than, or the probability of the adverse outcome seems to be greater than 1 in 10 power 6. I mean, think of this, smoking 1.4 cigarettes or living 2 days in New York City, again, but this data is from 1979. So now let's say we know the context in Indian cities, as in right now, I guess, recently in Delhi, the air pollution levels were so high, I believe that was during the sandstorm or dust storm though, that the level of air pollution was so high that the meter could not take the reading, I guess. We usually have air quality index and we measure PM 2.5 and PM 10 and such. The levels of PM 2.5 and 10 were so high off the chart that the meter could not, or the relevant readings could not be measured, right? I wonder what the relevant risk would be for, let's say, spending 1 hour or 1 day in what do we say, in Delhi, let's say, right? Anyway, a lighter note. So again, different aspects here, again, 30 cans of 12-ounce cans of soda, again cancer from saccharin, I believe this is regulated now, and so on. So again, from this context or from this set of example, we can see the idea of relative risk, as in 1 in 10 power 6 chance of risk, and we see that the type of risk, and we can compare the different activities that can lead to the adverse outcome, I guess. Again, this is on a lighter note, but to help you understand how the risk analysis can, what we say, let the decision maker look at regulations or policies, as in based on these risks, let us say they are going to, let us say, look at, okay, which of these aspects, what do we say, can I what do we say look at, or which of these aspects can I attenuate, let us say, by looking at changing or tweaking the policies and such, or where should my particular emphasis or resources be sent to, right. So based on that I am going to go through and look at the relevant aspects. So again, moving on, let us say, so the concept of receding zero is relevant in the not just Indian context, out there too, as in, let us say I take water from 10 years ago, not, I am not saying 100 years ago, 10 years ago, and water from now, let us say, right, let us say 2008 and 2018, let us say, right, and I analyze the water based on the instruments that, let us say, were available in 2010, and again based on the instruments that were available in 2018, let us say. So obviously though the picture is going to be different though, obviously why is that, as in water that might have been deemed to be safe might be deemed to be unsafe in 2018, why is that, because we do not have the relevant analytical techniques or the equipment to be able to measure some of these trace contaminants that might still end up causing some levels of toxicity or cancer in our particular body now. As in, why do I say receding zero, right? Earlier when we say zero, what does that mean? That means I could not detect the concentration below a certain level, and so people say it's the concentration of some contaminant is zero. But now because I have a better analytical technique, let us say, and my method detection limits are lower, let us say I can still detect the relevant compound even though it's lower than the method detection limit earlier, I guess, right. So again, that is one particular context. So in that context, I guess if you have TCE, let us say, or trichloroethylene, which is, I believe, toxic and carcinogenic in your drinking water, would you drink it? And most people, when I pose that in the class though, they say obviously, I guess it's a trick question, would say no. Some people would try to be smarter, yes, but again why would you, or the key here is you need to ask the relevant questions, as in the poison lies in the dose, as in any particular compound out there is toxic depending upon the level of or the amount of dosage. So just because TCE, a toxic compound, is present in your glass of water doesn't mean you need to look for alternatives. You need to know what's the concentration, let us say, of the relevant compound in this particular glass of water, and at this particular instance of me taking this or ingesting this glass of water, what are the risks associated with me what do we say, contracting that particular adverse outcome or such, right. Again, so the presence of mere chemical is insufficient obviously to warrant a harm. That is why we need to look at risk assessment, right. Just because there is some compound present doesn't mean I need to be alarmed. I need to know, depending on the level of usage of that particular or ingestion of that water, how often do I drink water, how much water do I drink, and what is the concentration out there. I need to be able to choose and then look at the relevant remedial options, I guess. And thus again I need to look at risk assessment. So obviously we talked about better analytical techniques in the context of the receding zero, as in water that let us say I deemed to be safe in 2010, let us say if I analyze it again in 2018, we because of what do we say, the proliferation of advanced analytical techniques, we can maybe come to a different conclusion that, let us say, the water in 2010 is actually unsafe, right. Again, unsafe in the context of having what do we say, compounds of concern, I guess, right. Again, receding zero. So purity past and present, I think I covered that. So in this context, I guess before we go for risk assessment, one aspect to consider is look at the holistic idea out there, right. So risk assessment, you are conducting that because you want to look at the risk posed to human health, let us say, right, and then you are going to put in resources now. But again, resources are limited resources, right, our resources are typically limited. So in general, how does a particular government go about, let us say, deciding whether to put in some particular or take some measures or such? If it's contaminated sites, depending upon the public outcry and political willpower, let us say, obviously it goes through. And obviously though we have regulations, let us say, or policy makers. So how do they decide, let us say, which particular aspects do I need to regulate, which one do I not regulate? So it obviously depends upon the amount of or the costs involved. And for that, obviously I need to look at what now, how much is a life worth, right. You still be able to put up a particular value to this particular what do we say, life of a human being, right. Only then can you come up with what we say, the amount of resources that you can spend, right. Again, I guess I'm slightly out of time, so we'll catch up on this particular aspect in the next lecture session, right? And thus far today we have looked at the relevant aspects or the background with respect to risk assessment. Have tried to emphasize, let's say, why do I need to go for risk assessment, and in the next class obviously we are going to look at how to go about risk assessment, I guess, right? And I guess with that, thank you for today, and I'll look forward to meeting you in the next session, I guess.